In this video, I will explain you magnetic moment created by a moving electron. Now let's see a moving electron as per Bohr's atomic structure. We have a nucleus here at the center and electrons are revolving in a circular orbit. So when electrons are revolving, we know electrons are charged particles, right? Now the charged particles are under motion. So when charged particles move, it creates magnetic field around it. We have learned that, right? Now, how to get magnetic moment? We have learned the equation M is equal to NIA. Now let's consider electron starts from this position and reach back to the same position. So how many numbers of turns are there? Only one, right? If we are considering electron starts from here and comes to this position again and comes to this position again, then that is 2 revolutions. But here we are only considering one, that is equivalent to one coil, current carrying circuit, current carrying coil having only one number of turns. Okay, so N is equal to 1. Now how to get the value of current? We know current is equal to Q by T. So in this case, what is the charge of an electron? Minus E. So minus E by what is T? T is nothing but time period for completing one revolution. So that is T. So negative sign represent that the current will be in this direction. Okay, so I am going to consider only magnitude here. So that is minus E by T. Now, how to get the value of time period? What is the total displacement distance it has to cover? That is the whole circumference, right? So if this is R, the whole circumference is 2 pi R. Okay, with a velocity of V, if it is covering 2 pi R distance, it is going to cover with V velocity. So what is the time taken? Time is equal to distance divided by velocity. Distance is 2 pi R divided by velocity is this. So I'll substitute this as time period. So that is 2 pi R by V. So EV by 2 pi R. We will get an equation in this way when I'm taking magnitude of current. Okay, so direction is nothing but opposite to this. Now, I got magnetic moment equation. What is that? EV divided by, I got the equation for current. That is EV by 2 pi R. Now to get the equation for magnetic moment, I have to multiply with N. N is 1 here. And I also have to multiply with area. What is area here? Area of this loop is pi R square. Okay. Now when we are multiplying with pi R square here, this will be pi into R square. So pi will cancel. R and 1 R will cancel. So I will have 1 by 2 EVR. Half EVR. That is the magnetic moment. Very important relation, this one. Now, we will do one thing. We will multiply it with M by M. So, magnetic moment 1 by 2 into E is charge of an electron, V is velocity of electron, R is nothing but radius, multiplying with mass of an electron divided by mass of an electron. So this is smaller, mass of an electron. I will tell you why I am doing in this way. So let me rewrite the equation in this way. E into MVR. So VRM is nothing but MVR divided by M. What is MVR? Angular momentum, right? So MVR is nothing but angular momentum of a moving electron. Now as per Bohr's structure, we have very important relation. Angular momentum is equal to NH by 2 pi. So let's keep this equation aside now. As of now, we will try to get the value of magnetic moment. Okay. So magnetic moment is equal to, instead of MVR, I am going to substitute angular momentum. So E into angular momentum divided by M. L. So I am going to take L this side. M divided by L is equal to E by 2M. This is very important. What is this? A ratio between magnetic moment of a revolving electron and angular momentum of revolving electron is E by 2m. E is a constant, right? 2 is a constant, right? M is mass of an electron. See, all the things are constant, which means that the ratio between M and L, what is M? Magnetic moment of revolving electron. What is L? Angular momentum of revolving electron. So the ratio between these two physical quantity is a constant. And on substituting the value of these two, E and M, we will get the value of M by L as 8.8 into 10 power 10 coulombs per kilogram. 8.8 into 10 power 10 coulombs per kilogram is the value of E by 2M ratio. Okay, make a note of it. So we got the value of M by L as E by 2M, which is a constant here. Now we will substitute this value here. Instead of L, as per Bohr's second postulate, L is equal to NH divided by 2 pi. That is equal to E by 2M. Now M is equal to N into N, this is N, into E into H divided by 2 into 2, 4 pi M. Please check the equation. M by L is equal to E by 2M. So for L we have substituted NH by 2 pi. So NH into E, in the denominator 2 into 2, 4, and M will be there, pi will be there. Yes, this is the equation for magnetic moment. And see one thing, H is a constant, E is again a constant, 4 is a constant, pi is a constant, a mass of an electron is a constant. Okay, so I can say that magnetic moment is an integral multiple of this value, that is EH by 4 pi M. So magnetic moment can be 1 into this value, 2 into this value, 3 into this value. So I am defining a standard quantity where N is equal to 1. So N is equal to 1 is the minimum case, right? So when N is equal to 1, I will get minimum magnetic moment. And this has been defined as Bohr magneton. So that is the minimum magnetic moment of a revolving electron. And when you are substituting the value of this, you will get the value as 9.27 into 10 power minus 2 ampere meter square. Yes, what is the unit of magnetic moment? I into A, right? So ampere into meter square. So this is the value. You can check the value once again with your textbook. So this is how you are going to get the value. So this is the minimum value. This one is very important, and even this ratio. What is this ratio called as? Gyromagnetic ratio. Gyromagnetic ratio. This one is a constant, E by 2M. Okay, make a note of it. Thank you.